So continuing on, your destination is 90 miles away. Your fuel gauge shows that you have about a quarter of a tank left, quarter of a tank of fuel left in your tank. You're 90 miles away. Your tank holds about 12.2 gallons of gas, and it also gets 25 miles to a gallon. So we have all sorts of different pieces of information here. We want to know if we need to stop to fill up or if we think that we're going to make it. And we're 90 miles away. So one way of doing this is just to take 90, divide by how much your fuel you're getting. So 25 miles per gallon. And we end up with 25 miles per gallon, not 20 miles per gallon. Shortchanging us already. So when we do this, we end up with 3.6 gallons that is going to be used to drive that 90 miles. So if we have a quarter of a tank left and we have 12.2 gallons to start with, so 12.2 gallons, and we only have a quarter left, so if I divide by 4, that means I end up with 3.05 gallons. So it looks like since 3.5 is less than 3.6, we're going to need to stop to fill up. So this is the mathematical way of, this is more the precise mathematical reasoning. But let's think about this in terms of just rounding some things, because again, you're driving, so you're just thinking about, okay, I know that I have a quarter left of 12.2. So a quarter of 12, I'm going to round down. That means I need 3 gallons. And if I'm going 25 miles to a gallon, so 25 miles per gallon times my 3 gallons that I approximately have in my tank, that means I can go 75 miles. And since 75 miles is less than 90 miles, I need to fill up. I need to stop. So this is the more realistic way of doing it while you're driving down the freeway. This would be the very mathematical. Again, it just says clearly explain, use sound mathematical reasoning. Either answer is fine, provided you're giving some information as to what you're doing. For number 6, again, possibly a straightforward question, but let's think about this. One of the things to note here, it says, so you're at a restaurant in Mexico and receive a bill for 1,170. Now you have this symbol right here. And actually, the Mexican peso uses one line as their symbol. The American dollar, the US dollar, actually uses 2. And the reason why the US dollar uses 2 and not 1, because many, many years ago, I guess I'll do this in black, our dollar symbol used to look like this. And it stood for the United States, the U and the S. And eventually, over time, this bottom part of the U got erased, and now we just have the 2 lines. So this is actually a Mexican peso. That symbol, I know with modern technology, everything only has 1 line, and so that's why it's confusing. So you'll see dollar signs, so you'll see something that has maybe the same thing, and then it says USD, or it might have 1 line 1170 CSD, D, so that's Canadian dollar. And then if you don't see anything, then you might assume that it's the Mexican peso, especially if you're in Mexico. So we're just going to Google 1,170 pesos, and it'd be Mexican peso because that's actually not a standard either, but because we live in the Southwest, it's pretty much, we assume that it's the Mexican peso to US dollars. So we're going to Google this. And so we just go to Google and type in 1,170. Now the interesting thing is that because our our dollar values are different and Mexican peso values are different throughout time. It's changing all the time. This little chart gives you that it keeps changing daily, actually. This dollar amount of $66.74 may be different today than it was even 7 days ago. So note for yourselves in my math lab, it's going to give you the actual conversion. So you want to use that conversion, otherwise you're going to get the answer incorrect. If anything that you're turning into homework for me, you tell me that you Googled it, then I'm going to know approximately when you Googled, and then I can go back and check. And so we see here this is actually $66.74 right now. So I'm going to put two lines, $66.74. I'm also going to say United States dollar, just to make sure that that is clear for everybody. Number 7 is just trying to figure out which one is a better buy. $3.99 for a 6-ounce bottle, or 14-ounce bottle for $9.49. If you divide those, you can kind of make that comparison, because right now there are different quantities, and so you want to make them all out of the same quantity. And probably price per ounce is probably the best way to go. You also notice if you're in any grocery store, actually just about any store now, usually on the barcode that gives the price, it also usually gives the unit price, that price per ounce or price per bottle or price per pound per se. All those things are that unit amount, so that you can do some easy conversion or comparison shopping. Number 8, get pulled over and the police officer tells you we're going 3,666 centimeters per second. Well, how much faster were you than the 75 mile per hour posted speed? Well, we're going to see if we can Google this. So we're going to try and Google 3,666 centimeters per second and see if we can get a direct Google 2 miles per hour. So let's try that. And if that doesn't work, then we'll have to figure out a different Google strategy. So just going to try this. 3,666 centimeters per second. 2 miles per, well, maybe it's going to give it to us. And it sure does. So it's amazing what Google can do. You just have to make sure you ask whatever you want. So it's 82.00608. So more than likely it's 82 miles per hour according to the police officer. So this is, we're going to say this is 82 miles per hour. So the ticket was for, what is that, 7 miles per hour over. Okay. Let's talk about population density. So population density is the number of people in an area, in a certain area. So the density is the number of people in an area, and most often we either going to say people per square mile, or you might say people per square kilometer if you're in a country that uses the metric system. So we want to know in Manhattan Island, so there's approximately 1.6 million people living in an area of 57 square kilometers. Okay, so that would be this, but we want to know what it is in people per square miles. So the first thing I'm going to do is I'm going to change our 57 square kilometers, and I'm going to change that, and I'm going to Google that to square miles. And so 57 square kilometers to square miles gives us approximately 22.0078. I'm going to use the entire number because it's not a very long number there. We want to be as precise as possible. So I end up with 22.0078 square miles. And so now I want how many people per square mile. So I want 1.6 million. Well, our calculators can't do 0.6 million, so we're going to write this number out, 0.0000 over 22.0078 square miles. Oops, that's an 8. And I'm going to divide these two numbers, and I should end up with 72,701.5 people per square mile. Then how does that compare to Rhode Island, which has a population 1,056 million people in an area of 1,212 square miles? Well, since this is already in square miles, I can just divide these two values and then compare it to the island of Manhattan Island. So if I take 1, again, this is in millions, so 0.56000 divided by 1,212 square miles, we're going to end up with 871.3 people per square mile. All right, so let me write that a little bit better. So we have 871.3 people per square mile. That's versus the 72,701.5 people per square mile. So Rhode Island is definitely less dense, and it's less dense by about, I'm just going to do very rounded math here. So this is 871, this is 701, so about 71,900, very rough math here, people per square mile. So they're less dense by about that many just by subtracting these two values. It's actually probably about 71,800. Okay, so again, it did say to compare. So we don't want to just say it's less dense. We want to say it's less dense by a certain amount. Again, we're just doing some rough math right in that place right there.